Welcome to Cyber Practice Episode 7. My name is Lewis Knox, and in this video, I will be demonstrating network segmentation and how isolating systems helps reduce lateral movement and strike security. What is network segmentation? Network segmentation is the practice of dividing systems in isolated network zones in order to control communication and reduce attack spread. By separating systems into different trust zones, organizations can better manage traffic flow and prevent unauthorized communication between devices. Segmentation is also an important part of zero trust security architecture. Why segmentation matters? Segmentation helps contain threats within isolated environments. If one system becomes compromised, segmentation limits how far an attacker can move across the network. It also reduces the attack surface, protects critical assets, and improves overall network security posture. This demonstration includes several important network and security concepts. VLANs and isolated networks help separate traffic between systems. Firewall rules and access control lists are used to allow and deny communications. Microsegmentation applies more granular security controls between workloads and services. In this demonstration, I'll validate communications between segmented systems, apply firewall restrictions, simulate block traffic between segments, and then restore approved communication path. This lab environment includes a Kali Linux virtual machine acting as a server segment and Windows 11 virtual machine acting as a client segment. Flash web application is used to simulate communications between network segments. Firewall enforcements will be performed using UFW rules inside the isolated lab environment. The workflow begins by validating communication between systems. Network firewall rules will be applied to block communications across the segment boundaries. Finally, approved traffic paths will be restored to demonstrate control access management. Now we're moving into the live demonstration portion of the lab. To begin, I will navigate to the segmentation demo directory on the Kali Linux virtual machine. This directory contains the Flash application and files used to simulate segmented network communication. From here, we'll launch the application and begin testing communications between systems. Here we can see the Flash web application running on Kali Linux virtual machine. This system represents a segmented service hosted inside a controlled network zone. In this scenario, the Windows 11 virtual machine will act as a client attempting to communicate with this service. Next, I'll move over to the Windows 11 virtual machine to test connectivity. As we see, Windows Systems is currently able to access the web application successfully. This demonstrates normal allowed communication between segmented systems before any restrictions are applied. At this stage, traffic is permitted across network segments. Now that communication has been validated, we'll begin enforcing segmentation controls. I'm opening the second terminal and applying a UFW firewall rule to deny traffic on port 5000. This action simulates segmentation enforcement by restricting communication between network segments. In real enterprise environments, firewall rules like these help organizations control which systems are allowed to communicate. Now return to Windows Virtual Machine and attempt access to the application again. After refreshing the browser, we can see the connection is no longer successful. The Windows systems can no longer communicate with the segmented service because the firewall rule is actively blocking traffic. This demonstrates how segmentation controls can prevent unauthorized and unnecessary communication paths between systems. It also helps reduce lateral movement opportunities during security incidents. Now I'll restore approved communication by modifying a firewall policy. I'm now allowing traffic back through the firewall on port 5000. This represents controlled access restoration between segmented systems. Rather than allowing unrestricted communication everywhere, segmentation allows administrators to selectively approve trusted traffic paths. Now the key takeaways. Network segmentation helps reduce lateral movements by isolating systems into controlled communication zones. Firewall rules and segmentation policies helps organizations control which systems are allowed to communicate. Microsegmentation strengthens zero trust architecture by enforcing security boundaries between workloads and services. Overall, segmentation improves containment, reduces attack speeds, and strengthens enterprise security posture.
Thank you for watching Cyber in Practice. If you enjoyed this demonstration, stay tuned for future Cyber in Practice episodes.